In this lesson, we're going to look at a nice example and analyze some probabilities. And again, it will come down to using our formula for probabilities when the outcomes are equally likely. However, in this example, we have to be careful to specify the outcomes correctly. Otherwise, it's easy to make a mistake. So the example that we're looking at is that of rolling a pair of dice. So again, we have standard six-sided fair dice, and we roll both dice, and we're interested in the probabilities of various totals. So let's list some events that we might want to calculate the probabilities of. So let's say we wanted to calculate the probability of rolling a total of 7. Or we might be interested in the probability of rolling a total of at most 3. And we could list various other events that we might want to calculate the probabilities of. Okay, so how do equally likely outcomes come into this? It's very tempting to reason in the following way. And I'll put it in red because this is incorrect. You might say that the possible outcomes are 2 up to 12. When you roll a pair of dice, the possibilities for the total score are 2 to 12. That's true. And you might argue that these are equally likely. So that means that the probability of a total of 7, that's one of these, is 1 over 11. There are 11 of these outcomes here, 1, 2, 3, 4, up to 12. And so if they were equally likely, then the probability would be 1 over 11. It's very important to realize that this is wrong. And the reason it's wrong is because these are not equally likely outcomes. We'll see why this is true from a theoretical point of view in a few minutes, but we can also simulate this using an Excel sheet, and we'll see from the Excel sheet that these outcomes are not equally likely. So here's an Excel sheet that I've set up to simulate this experiment of rolling a pair of die and calculating the total. And you can see there are various different parts to this sheet. Here in columns H and I have the results of the two die rolls, and I'll show you how to generate those in a minute. And then on the left hand side here we've got the yellow section which keeps track of the frequencies of the various totals, and here in blue we'll keep track of the relative frequencies. And you can see there's nothing here at the moment, so that's why we're getting this strange error messages here. And down here in grey, this number down here is the total number of trials that we've run. Okay, well let's see how to simulate the two die rolls. So what we do is we get Excel to generate a random number between 1 and 6 for each die roll. So there's 1, it's rolled a 3, and I want to do it for the second die as well. And now you see it did the first one again, so I've rolled a 6 and a 1 in this trial. And you can see that the frequency tables now have changed. You see I got a total of 7, and that's appeared with frequency 1 now. And I have one trial, which is correct. I've rolled a pair of dice once, so I have one trial. And here's the relative frequency. So the relative frequencies are just the numbers in the yellow section divided by the total number of trials. Okay, so let's get it to do a larger number of trials. So I can do this just by dragging these cells to cover several rows. So here I've done 9 trials, and you can see our relative frequencies here now. So we never got a total of 2 or 3 or 7 or 10 or 11 or 12, and you can see the relative frequencies of 4, 5, 6, 8 and 9 here. Okay, so there's not really a pattern there. Let's take a bigger number. So now I've done 34 trials, and you can see some relative frequencies here. So still not much of a pattern. we notice from the frequencies that the total 7 occurred 7 times here, so it occurred quite often. Let's take a very big number. Let's drag this down to maybe 400 or 500 or so. Okay, so we've had 450 trials here now, and you can see that the events rolling a total of 2 and rolling a total of 12 seem to be quite rare here. 0.0378 and 0.02, whereas the ones in the middle, 5, 6, 7, and 8, occurred a lot more often, and you can see that from the frequency tables. You see, look at 5, 6, 7, and 8. Well, they all occurred at least 50 times. So let's push it out a little bit more. We'll go down to maybe 2,000. Let's say 1,900 or so. Okay, so we have 1,990 trials there, and now we can see quite clearly a pattern here that the very small totals, 2, 3, and 4, and the very large totals, 10, 11, and 12, occur less frequently than the ones in the middle, 5, 6, 7, 8, and 9. Okay, so what's going on here? Well, let's try and explain this from a theoretical point of view. Okay, so it seems clear from our experimentation that the totals are not all equally likely. So what was wrong with this idea that they would be equally likely? Well, the problem is that these are not really the outcomes of rolling a pair of dice. To list the outcomes of rolling a pair of dice, perhaps the easiest way is to use a two-way table. So we want to make a two-way table listing all the possible outcomes. Along the left here, we've listed the possible outcomes when we roll die 1, and along the top here, we've listed the possible outcomes when we roll die 2. To fill in the table, we just match up rows and columns in the following way. So we have 1, 1, 1, 2, 1, 3, and so on. So the first entry in each cell comes from the left-hand column here, and the second entry comes from the top row. So we can fill in the table like that. So we can go the whole way through the table, and this is what it looks like when it's filled in. So now all of these outcomes are equally likely. So how many of them are there? Well, there are 6 rows and 6 columns, so we get 36 possible outcomes. Okay, so we have 36 equally likely outcomes. So now let's consider some events and calculate their probabilities. So for example, we might want to calculate the probability of rolling a total of 7. So what do? Well, we go through the table and we find the outcomes that correspond to this event. So I'll circle them in blue here. So which outcomes give us a total of 7? Well, 1 and 6, 2 and 5, 3 and 4, 4 and 3, 5 and 2, and 6 and 1. And none of the other outcomes give us a total of 7. So how many did we get there? Well, 6. So 6 outcomes give us that event, and the total number of outcomes is 36, so the probability is 6 over 36, which is 1/6. What about the probability of rolling a total of at most 3? Well, we can calculate this in the same way. We look at this table and we pick out the outcomes that correspond to this event. So which outcomes give us a total of at most 3? Well, 1 and 1 certainly does. 1 and 2. 1 and 3 doesn't work. What about 2 and 1? That works. And that's it. Every other outcome gives a total of at least 4. So these are the only 3 outcomes in our event. So there are 3 outcomes here and a total of 36 outcomes. So this probability is 3 over 36, which is 1 over 12. Let's look at some other events. What about the probability of a total of 9? So again, we go through our table and look for the outcomes that give a total of 9. And we see here 3 and a 6, 4 and a 5, 5 and a 4, and a 6 and a 3. So there are 4 of them. So we get 4 divided by 36, which is 1 over 9. And it's a good exercise now. You should go through this table and you'll see that the total that's most likely when you roll a pair of dice is 7. If you try 6, you'll find that the probability of a total of 6 is 5 over 36. And you can check all the rest yourself. You'll find that no other total is as likely as 7.